Thank you for the invite to talk about our project. I work with Professor Liz Varga on the Circular Economy Center of Mineral-Based Construction Materials. Today we will talk specifically about this case study, which is on maritime shipping digital twin for construction waste distribution. Our industrial partner is National Highways. Just a brief overview of what we will be talking about, an introduction of our project, and just the concept behind circular economy and why we chose to do a maritime shipping digital twin case study. Some innovations in shipping that inspired us to do that. The concept of the digital twin we are trying to build. And just a few details of what we've done so far. So our center is the Interdisciplinary Circular Economy Center for Mineral-Based Construction Materials, and we are part of the third group of systemic enablers for circularity, and specifically our project is on eco-design measures. Our project aim is to characterize these mineral-based construction materials in infrastructure case studies with the application of circular economy principles. And our final goal is to create 3 case studies from infrastructure projects. And one of them is the maritime shipping. The expected impact from that, which is also relevant to this conference of environmental impact, is to validate an eco-design framework with actionable interventions in transport infrastructure specifically, to create business practice changes, to use digital technology, to create a wastage management system for MCMs, natural resource management over design problems in these infrastructure projects, and collaboration of stakeholders. So some of the eco-design principles that we have found from our literature review relevant to circular economy of these materials are modular design and construction, reuse of waste products and assets, use and distribution of waste materials, data and intelligence, modal integration, natural environment impact, maintenance and durability, and the human factor. And how this relates to our maritime shipping case study is the specific principles that relate to that are the use and distribution of waste materials, the data and intelligence, hence we're trying to build a digital twin, modal integration, natural environment impact, and the human factor. And I will explain shortly how this is relevant to this project. First of all, this is some data from the Mineral Products Association. And since our focus is cementitious materials, this shows the trend of cement material production from 2001 to 2021. And also, it shows with the yellow, purple, and blue line, well, the purple down here, the important cementitious materials. And this is why we're focusing on maritime shipping, because we realized that there is an increase of imports of cementitious materials, so it's not all produced here. And this can also clearly be shown here, where we can see an upward trend of this is the percentage of imports to total cement produced and imported in the UK. So we can see an upward trend here, and this is something that triggered us to think of innovative ways of transporting waste materials, and not only waste materials actually, the actual materials that are used in infrastructure projects. The second reason that we want to do this is I don't know if there are any civil engineers in the room, but there's a rule of thumb from the 1950s, the Generalized Fourth Power Law, which actually shows us that the impact that the axle loads have on pavements and on roads in general. So the stress created on a road is proportional to the fourth power of the axle load of a vehicle. So if we think about a truck transporting waste or transporting any type of material and how heavy it is, we can actually understand that if it's proportional to the fourth power, that the damage created is huge. So the next thing that made us think that it's really important to think about new ways of shipping materials is the fact that maritime shipping is based on two contractual pillars. And with after reading this article, which you can find on the link, it proposes a third pillar, that of the decarbonization. So that would entail a contractual framework for decarbonization actions and measures that will trump commercial orders, but will always have in mind safety. So the two concepts that this article talks about is the steam fast then wait, which is essentially the fact that ships sail to the port of destination at their service speed without regard for the conditions at that port. Largely as a result of this, dry bulk carriers and tankers spend about 8 to 10% of their entire life at anchorage. If we avoid this, and that means if we use the just-in-time concept practice, that means that would result in emissions reducing to the order of 20 to 25%. And why this is relevant to what we're trying to do? Well, I'll explain this in a bit. This is just to show also some innovations that have inspired us in shipping. One of them is autonomous electric maritime shipping, which has a common policy framework with autonomous vehicles. An example is the Yarka Birkeland in Norway, and the Oceanbird wing sails, which also reduces cargo carbon emissions by 90%. So after seeing the innovations that are happening and where maritime shipping is going, we decided to choose this as our case study. So we want to modify the way waste is distributed, and in order to do, and we want to minimize trucks off the roads for the reason I mentioned, and also create a modal integration of roads and transportation. So we intend to use live tracking data from websites that track vessels, and especially we're interested in cement carriers or carriers that are actually affecting our project, which is mineral-based construction materials. And there will be a daily location update which will be connected to our database. We want to estimate the daily distance traveled of the ship and the emissions produced, and actually calculate the required daily travel and see if the ship is rushing or not, and give back the feedback that you are rushing or you need to go with that speed. And essentially creating a digital twin that will aid in reducing environmental impact. So the things that we are thinking about are, so we're going to be focusing on cement carriers, on ships bringing in required materials for infrastructure projects, and also the way to get rid of these materials or any waste created. And we will also be thinking about in the future the digitalization of ports, autonomous electric ships, and another focus that has come up is on domestic transport of construction materials via sea, for example, via one UK port to another one, with no need of using roads. So we're currently using marinetraffic.com for its API services. We have found specific cement carriers that provide us the data that we need in order to progress with our project. These are some of the data that we are using. We're specifically interested in destination ETA, timestamp, position location. And this is just an example of the data we are interested in. So the MMSI is kind of an identification code for the ship, the latitude, longitude, the timestamp of where the ship is at currently, and destination and ETA, estimated time of arrival. So regarding all that, our utmost goal is to also look at the emission impact of shipping. With this digital twin, we'll be able to estimate the carbon emissions of a shipping journey. And there is also going to be potential emission savings from if the digital twin advice is followed. There can be a direct comparison of what would happen if it wasn't followed, and then we can actually see the savings potential of emissions. And also in the future with electric ships. These are our contact details, and we look forward to working with DAFNI in order to create this. Thank you.
Thanks very much, Ruby. Thank you.